Hi, this is Brandon with Balls on You. I'm going to discuss the mechanism we use to generate a pump uh, for the coin pump on VaporDEX. In this video, we'll provide an introduction, we'll discuss ways to fix the charts, we'll discuss the approach we use, we'll then discuss the formula for a liquidity curve, and then we'll show you how you calculate the impact and then finish up the video. Does the chart on the screen look familiar to you? It should. Most meme coins follow a chart that looks very similar to this. If you look at the liquidity during the first pump, it's normally low and increases dramatically during the first pump. As people sell the coins, go back into the LP, but the LP is still thicker because there was thousands or millions of trading volume providing revenue. Then the next pump needs way more volume to reach the previous all-time high. Most never achieve it. That's why I started looking for ways to fix this problem. There's two main ones that I see projects use, but how they use it impacts whether it works or not. The first way is to thin an LP. This makes it easier for a coin to pump when you thin the LP. Thinning an LP is taking AVAX and the coin out of the LP. It will make it easier for the same trading volume to have more pronounced results. But what the project does with the coins they pulled out matters. Do they burn it all, keep it all, or use it for other things? You have to decide whether you trust what they do or say. And that's something that's kind of hard. I feel like I've proven to anyone who's interacted with me that I will do what I say. And furthermore, that I will enact the will of the community, even if I don't like it. And that's fine. Like, I just want to do the best I can and help build a community that has a lot of fun and gets great results. So when I say I'm going to burn it, I'm going to burn it. I'm not going to save it for myself. I'm going to burn it. I'm going to show you the address, the transaction where I burnt it, and you know it's burnt. When I say I'm going to use the AVAX to buy back pump from the LP, that's what I'm going to do. So, I think that's really important that you have to trust whatever's done, even if it's by code. I mean, it's easier to trust a person than it is code because let's face it, most of us cannot read code. So we can't check to see if it actually does what it says it's going to do. If I tell you that I'm going to burn something and I provide you the proof that I burnt it, you can verify that. And that makes it pretty easy. The second mechanism you can use is burning a coin. Burning a coin lowers the total supply, which makes each person's holdings a greater percentage of the current circulating supply. This is basically a way to manipulate the supply and demand curve. So next we're going to discuss how we use these to create a pump. Our approach to creating a pump works like this. First, pull part of the LP. In our scenario, we're going to pull up to 50% of our available LP. And that's only the team supply. That does not include any LP that other people have put into the liquidity pools to help support the project. Once we pull the LP, we're going to burn the pump by sending it to the OEX, whole bunch of zeros, DEAD wallet. It's the dead wallet. It's the burn wallet. It's got millions of dollars worth of coins from pretty much every single project on Avalanche. Um, then we're going to break the AVAX into several different pools. At the start, the way it's going to work is 50% of the AVAX is going to buy back more pump, and we're going to burn that too. So you have two burn incidents, but the truth of the matter is I will combine them into one transaction because, let's face it, we don't need to waste gas. So then the third step will be to buy back 20% of balls and use the other 30% for up to 3 other incentives. We may change these numbers as we go. For instance, at the end, I'm going to explain why I might need to change those numbers to where it goes to 70% of the AVAX is spent on pump and 20% on balls and 10% on one other initiative. But how does this all work? How do you actually calculate what it's going to do? I'm going to explain that next. All right, so you have to understand the formula to calculate an LP curve. It's pretty simple. It's X times Y equals K. X is the representation of the first coin. In our case, it's going to be the quantity of pump. Y is a variable to represent the second coin in the pairing, which is AVAX. So the third number, K, is a constant. Basically, it's what you get when you multiply X times Y. So, for instance, at the given moment, we have 72.84 billion balls and 116.42 AVAX. So we'd multiply those numbers together to get some number that's in the trillions. Now, if one of the liquidity providers pulls out a portion of their liquidity, K changes. If a new liquidity provider adds liquidity, K changes. But when you swap pump for AVAX or AVAX for pump, K stays constant, which means we can use this equation to, one, figure out what our liquid, to understand our constant before the pool, a pool of liquidity. Two, we can use the constant to figure out what it is afterwards. And then we can use constant divided by AVAX to figure out what it would be after the buybacks. So we use this equation a lot, and it's the foundation to being able to figure out exactly what will the impact of this be. Let's look at an example. We're going to calculate the impact of pulling liquidity, burning liquidity, buying back pump, and then burning more liquidity. I already calculated all the numbers using an Excel. Well, it's actually Google Sheet spreadsheet to make it easier to do these calculations. So when I did the calculations, we had 70.78 billion pump and 119.78 AVAX. which means you need to solve for K. When you multiply X times Y, you get eight 0.478028 trillion, or around 8.5 trillion as the constant. The team only owns 70% of that, which means you need to adjust the team share to look like the values below. 4.9546 billion pump, 83.85 AVAX, and a constant of just under 6 trillion. Other LP providers hold 21.234 billion pump, 35.93 AVAX, and there's like a 2.54 trillion K. We cannot pull the other LP providers' liquidity, so we only have to work with that 83.85 AVAX. So in the second step, we've pulled an amount. So let's assume we pull 50% of the liquidity, which means of the liquidity that's owned by the team. That means we'd pull just under 25 billion pump and just under 42 AVAX. That would leave the liquidity pool after pulling a part of the liquidity at 46 million pump, 78 AVAX, and around 3.6 trillion constant. So at this point, the liquidity pool looks much different than beforehand. So in this next step, now we're burning pump. At this point, we have the 24.7 million, 24.8 million billion pump, and 42 AVAX out. The 24.8 pump will be burnt. So you're going to need to remember that later in the presentation. But then we have with the 42 AVAX, we're 50%, or approximately 21 AVAX is going to buy back more pump, 20% is going to buy back balls, and 30% for other initiatives. So in this step, we're going to calculate the impact of the buyback. From step 2, we know the LP looks like 46 billion pump and 78 AVAX, which creates a constant of around 3.6 trillion. We also know that we're going to buy back just under 21 AVAX worth of pump. So we adjust Y from 77.86 to 21, and we need to add 21, which is going to make that go up to around 99 AVAX. We can use the formula X equals K times Y to solve how much pump we have. When you do the calculations, that leaves 36.25 billion pump in the liquidity pool. So you'll need to subtract that 36.25 from the liquidity pool, which was at 46 billion. That means we bought back around 9.759 billion pump. which means it's realistically taking around 2% of the supply out of it, 2% out of the supply that will be burning from that. And then you also have the other amount, which we'll discuss in a minute as well. So, how much is burnt and what is the price change? In step 3, we have 24.773 pump, and in step 4, we have 9,759,000,000 60,606 pump. That means we'll have around 34.5 billion pump that will burn, or 8.21% of total supply. The price would increase 61% from a bunch of zeros, 0.1692 to a bunch of zeros, 2726, and that's measured in AVAX. In dollars, it would actually lose a decimal. And my original calculations, I forgot 30% of the liquidity was other people's. That means we'll likely need to adjust the amount of buckets to 70% pump, 20% balls, and 10% a third coin. I'm going to request a vote before doing so, but this would guarantee that the pump goes up enough to more than double pump's price. So that's the purpose of changing why I do that. I hope this presentation was helpful. It's meant to help people who want a better idea of what we're doing, understand how we're getting those daily calculations of what would it do to the price of pump if we did the pool today. So I think this is a really interesting experiment. I think it will help people. I hope it will help people understand more how liquidity pools work, because one of the things in decentralized finance that's really hard to understand is how the liquidity pools work. And if you're using them for trading, like, you don't really need to understand but a lot of the technology today, like when they tell you how much you're holding in your wallet, those prices aren't right. Those prices are doing the current price times the number of coins you hold, which means it's showing you way higher than if you actually sold it. Especially when you own large amounts of something, a lot of liquidity pools only really have 10% of the liquidity in them, which means if you're selling 1% of the liquidity, or 1% of the total coin volume, you're going to impact the price by 10% or more. And most people don't realize this. So I'm really hoping that this helps you. If you appreciated this video, give it a like, give it a share, let other people know what's going on. I really hope you did appreciate this, because this took about 6 hours to create, but I think it's a really valuable thing for people to understand. Thank you. Have a wonderful day.